I'm Julian.
There are two basic areas in the kit. This is the grid users area, and this is the grid operators area. And I'm going to explain to you what's on the grid operator station here. So the grid operator station is a model of power plants here, and the grid operators, controls, and instruments here. Each power plant, and we have 3 of them, consists of 2 AA batteries. These are real non-renewable energy, just like a coal, oil, or natural gas plant. So this is one power plant here, second and third. These are the switches by which the grid operator can bring a plant online. These are the meters that the grid operator has. Turn the meter on here. You can see the LEDs, and we're on the 5-volt scale, so you can see we've got about 2.75 volts right here on our grid station. And you see if I don't have anything hooked up, you don't get any voltage. So we'll hook up one power plant. This meter tells you how much current is flowing. So you set it to amps DC, which, let's see, where's amps DC? Right there. And it tells you how much current is flowing. Right now, nothing's hooked up, so no current is flowing. The job of the grid operator, just like in the real grid, is to maintain voltage on the grid at all times. In our model grid, we want 2.5 volts. Let's see, why are we not getting any voltage here? Oh, we got a loose connection. There we go. Okay, we got 2 3/4 volts. And no current is flowing because we don't have anything hooked to the grid. The grid operators, as more loads are put onto the grid, they have to dispatch or turn on additional power plants. So there's nothing going right now, so one power plant is plenty. As we get more loads on the system, the operator may have to add additional power plants in order to keep the voltage up on the system. If on the real grid, if the voltage isn't kept up to 120 volts in everybody's houses, it will damage things like refrigerator motors. So it's very important that the grid stay up at its required voltage. In our model grid, that's only 2 3/4 volts. One of the differences between the model grid and the real grid is this voltage. 2 volts is not dangerous. 120 volts on the real grid is very dangerous. So this has all been set up to be safe voltages. All these components in here are designed to make the thing operate properly. And yeah, so that's the grid operator station, and I can put the power plant covers on here just to make it feel like a real power plant with little smokestacks and everything. This is the high voltage transmission line in the real grid. In our grid, of course, everything is 2 3/4 volts, so it's really low voltage, and it has to be a thick wire to carry all the current that's going to be needed. We put the grid operator station in a remote part of the classroom or even in another room because in the real world, the grid operators can't see what the grid users are doing. And they have to control the grid essentially blind of what's happening on the other end. So we have this long transmission line, and we'll loop it around the leg of the table here so if somebody trips on this wire, we don't take down the whole grid. And we'll bring this over to the grid users area here, and we'll hook it on. So there's a connection, and you can see that this little blue LED lit up to indicate that there is voltage on the grid. And the LED's been chosen that if the voltage gets too low, this will get very dim. So that's a good visual indicator without having to look at the gauges about the voltage. In the first lesson, students will hook up the lighting in a house. They'll use an incandescent bulb, these Christmas tree bulbs, and you can just put them right in like that, and that'll put the light bulb in the house. And they'll use 3 LED lights, and we've got some red LEDs here, so we can hook these on here. And we need to get power from the grid to our house, and for that we've got these wires to go from the house to the grid, which we can untangle one of here. All right. So these are the wires you use to connect each house to the grid. So being a complete circuit, we need one on the positive and one on the negative side. And then we need to hook the other end to the house here. Now, one end can go on the positive side and one on the negative side. Now we've got this switch right here on the house, and that's to be able to disconnect each house from the grid. So I'm going to connect this in such a way that the power has to go through the switch to get to the house. That way I can disconnect the house. You'll see why we want to be able to disconnect the houses in a minute. All right, so now I'm going to hook up my incandescent light bulb here. So I get a clip lead on one side and a clip lead on the other, and they're sort of fussy, these clip leads, but they work. And then we hook the other side to the positive and negative here, and let's see if we get some light. Ah, no light. Ah, it's not turned on. Okay, turn it on. Do we get some light? Yes, we've got light. Okay. All right, let's disconnect it. You can see it drops the voltage a little over here. So the grid operators are, because that got dim, so the grid operators are going to have to add some more power on their end. Now let's hook up an LED. So I've got one on the positive, one on the negative, and I'm going to hook these to the bars on the house. This is kind of like hooking to the circuit breaker panel in your house. Oh, did we get any light here? Our power's not on. All right, let's try that. Probably will work better with the power connected. And we have to get the polarity right. We've got to get the positive to the positive. Ah, there it is. Okay, we got light there. Put that one in the house. And so on. You just do this until all 4 are hooked up. There, now we have our 4 lights. 1 incandescent and 3 LEDs in the house.
All right, well, Andy, you have this one house hooked up with 4 lights in there, 1 incandescent and 3 LEDs, but obviously you know we don't just have one house in our neighborhood, we have several, so we're going to add a little bit more load to the system by hooking up a couple more houses with lighting.
So we hook each house to positive and negative, each house to positive and negative back at, this is like our circuit breaker panel in our house with the power coming in from the grid. And oh, I've done something wrong here, I can't disconnect it. So I want to make sure that you always are able to disconnect each house so that if there's ever any problem with a house, you'll be able to disconnect it. So I'm going to just leave it unhooked while I start to, here I got my incandescent, here's another incandescent for you, one for me.
And one problem that I've sometimes encountered is when you hook it up to the grid, please make sure that the 2 leads, the alligator clips, are not touching each other, because that'll short it out and we won't get a complete circuit.
Yeah, so I'll turn the power on and you'll see the blue LED should be lit here. Let's see. Oh, it's not lit. Why is that not lit? There we go. These 2 are shorted together. They can't be touching either. So the little blue LED shows that we've got some power at the neighborhood grid. Okay.
And as Andy showed you, sometimes you notice that things are not going on, or this is on very dim, but sometimes jiggling a wire or making sure the connections are clean really helps out.
Is that first house turned on? Why don't you turn that one off and that'll help
I'll turn
us
this
through.
house off now.
Oh, see that brought up the voltage because it decreased the load. These incandescent light bulbs put a pretty significant load on the
I have one bulb on here.
Okay. And when I hook it up, I like to hook up one thing and then put the power to it and see if it works. Let's see. Yep, it's working. Okay, now I know that one's okay, then I'll hook up the next. There's some very basic troubleshooting skills that come with this, which is being able to separate out each little piece that you've put in here to see if there's a problem with any one. And you'll see that the students will get short circuits and all kinds of things going. Okay, let's see if that one's gonna work. Nope, that one's not right. I wonder if I got it backwards. It is an LED, right? So the polarity has to be right for the LED. Oh, that's right. Okay, now we got that one.
And Andy, that's good advice. Between each set of bulbs, if you disconnect it, we do conserve a little bit of the battery strength.
Yeah, that's it.
So Andy, what you're doing is you're putting the leads, both leads to the LED light first,
Yeah,
and then using this to hook to the house current to make sure you have the correct.
so I got all my lights on? All my lights are on. Let's see, I can disconnect right here or turn it all on again.
All right, so this works for me,
So there, this house is all hooked up.
and then this house is all hooked up. And let's hook this house up, and all the lights are on here. Should we check the grid operation station?
Oh, okay, grid operator, how we doing? Okay, we have 3 houses on, each with an incandescent and 3 LED light bulbs. And we found out that when we put all 3 power plants on, we can't get up to our required 2 3/4 voltage. So we have here a connection point for more generators. This is just like the real grid. When their normal power plants can't handle it, they bring in a special power plant to handle the peak high power demands. So our peaking power plant is a hand crank generator. And notice that when you hook this up, it runs as a motor, because what's in here is a little DC motor generator. When you apply electricity to it, it turns just like a motor. But if you crank, it adds power. So crank it, Julian, and watch what happens. So when he cranks, we get higher voltage. Stop for a second, you'll see the voltage goes down. Now crank again. So the peaking power is supplying the correct voltage to run all of our houses now. So now let's do the next lesson, which is we have
Replace.
a program, an efficiency program is going to replace all our incandescent light bulbs with LEDs. So let's go to the houses and swap out the incandescents for the LEDs. Okay.
So
there's
right
my
now I'm taking out
incandescent.
the incandescent bulb.
All right, I'm going to turn the power on so we can see what we're doing.
Very good. There are lots of programs like this out right now where they're trying to minimize the amount of electricity used for lighting.
And these
don't
are
forget, you have to push them the right way.
these efficiency programs are a big win for everybody because you get the same services. I got all 4 of my lights going, but we'll see if we're using less power here.
Now we have 3 houses hooked up. This kit has up to 10 houses. You could expect basically the same results. When you're adding the supplemental power, you might have to crank it a little bit harder, and you can actually hook up 2 hand crank generators to that, so you can have 2 students doing it to maintain the 2.75. Now we're looking at 3 houses, all with LED bulbs.
So back here at the grid operator station, when I have 1 power plant hooked in, I'm at 2.5 volts. I hook in a second one, I've got my 2 3/4 volts with just 2 power plants. When we had those incandescents running, we had to have all 3 power plants plus our hand crank peaking generators. So you can see the value of efficiency here. It's allowing us to use less of our non-renewable energy. Now we're going to add refrigerators. You can see with just with the LEDs and 2 power plants, I can maintain our voltage and our blue indicator lights nice and bright. Now let's put a refrigerator in each house. So we have a box of motors. As you may or may not know, a refrigerator has a motor in it. That's what runs the compressor and keeps everything cold. So, of course, we can't have a house without a refrigerator these days, so we're going to add a refrigerator to each house. So that means you got to hook up a motor and have it running. So, just like the light bulbs, you got to connect the positive and negative and hook it up to your household power panel, which are our 2 bars on the top here, our 2 big bare wires. And let's see if we got this running. Whoop, there we go, it's running. All right, got that fridge going. Whoop, I seem to have
Mine isn't.
okay, let's see if I can get this one going. They got little tiny wires on here which are a little fussy.
And make sure you tell students you have to go metal to metal. Don't have them grab the insulating plastic around the wire. There is a lot of trial and error with this, and patience.
There's two refrigerators running. One,
And
two.
I have mine.
All right, let's see what happened over at the power plant. I had my two power plants were enough to handle all the lights, but now that I've got the fridges going, I'm down to 2.5 volts. I need to get the voltage up. Boy, even with 3, we don't have quite enough power here. Let's hook
Need
on
some
the
supplemental power.
peaking generator here.
And again, metal to metal.
And you notice that that crank will turn by itself before you start to turn it. You just turn it the same direction. All right, we're back to 2 3/4 volts. The grid is happy, but we have to have our peaker plant running in order to keep our voltage up where it needs to be. So that you can see these motors draw a fair bit of current.
Now we're going to simulate adding another device to your house, an electric car. And we're going to do that by adding another motor to the setup of the house.
This is my electric car.
And if you notice, we are hooking everything up in parallel. It means that each device is going to the same 2 wires in your house.
Okay. All right, I got my car running, I got my fridge running, I got my lights running. Let's see what's happening over at the grid. Even with just that one IL, the voltage has dropped from 2 3/4 down to 2.5. So we're going to need a peaking power plant. Okay. Remember, when you hook these things up and turn, when you add power, you turn in the same direction. All right, I can turn this pretty easily and get my power up to where it needs to be, 2 3/4 volts. Have we got all hooked up?
We have 2 motors on each house representing a refrigerator and electric car, and they are all moving, and 4 LED lights. Yes, we do.
So you can see when we add electric cars onto the grid, we're going to have more power to support it, or find more efficient ways to use the power we're using.
There are ways to rewire things so we don't use quite as much energy and maybe not need so much peaking power energy added to the grid.
So right now we have everything hooked up in parallel. That means the plus from each motor goes to one side of our neighborhood grid and the minus goes to the other. If we connect them like this, more like holding hands in series rather than in parallel, we'll only have half the voltage going through each motor. That makes the motor use much less power. So this is simulating an efficiency program where we decide we're going to put special controls on our refrigerator motor and our electric car motor to make them run more efficiently. So let's hook them up in series now.
Yes.
So we got to take
I'll
the
take this one off.
off of there, and we're going to hook that to one side of the motor. So now the power comes through one motor and then through the other motor and back to the other side, like holding hands in a circle. So let's do that to the other 2 houses too.
Now this might take some time for the students to do, and it will get messy with the wires, but that's all part of this learning process.
And if the students haven't had series and parallel circuits in your bulbs and batteries program, or however you teach electricity, they might not understand exactly what's going on here. But it does result in lower power consumption.
Very good.
Okay, let's hook up the grid.
Put us online.
Okay, and now I'm able to maintain 2 3/4 volts with 2 motors running in each house without any supplemental peak power generator.
Wait.
Just the 3 power plants.
Now we have all 3 houses online.
Yeah, they're still 2 3/4 volts. The 3 power plants by themselves we go, let's see what we can do with 2. Yeah, we can even do it with 2 power plants. So this is a lot more efficient way to run those motors. We have a central large array solar system, so photovoltaic array that can be hooked up to the grid. This is a model of the big arrays you see out on the ground periodically around Vermont. So we've got 4 panels in here, and we're going to hook them up in parallel. So we're going to take all the red wires, the 4 red wires, and we're going to connect them all together. And we're going to add in a little extra wire here so that it's easier to hook them all up. So this would be a little fussy. I tend to twist them together a little bit, and then I take the wire nut. It's called a wire nut because you can just turn it right on there and it grabs all those little wires and puts them all together. So I'm going to take the reds on one side, and Julian's got the black ones here. Here's one more. So we got all the reds hooked together and all the blacks hooked together. And here's our lead where we're going to be able to connect in. And then we've got this very long cord. And the reason this is so long is that you need real sunshine to do this, generate any significant power. And you need to put it outside in the sun. And that's why we've got this long cord. You can drop it out the window. So we hook that up to the red here. And I'm not going to unwind this whole cord right now. And then on the other end, we hook it up to the power grid. Remember, this is the same place we hooked up our peak power plants, our hand crank generators. And you hook them up to the same place here. This is a connection point for more generators of any kind. So now this is all hooked up. And if it were sunny, we'd take this outside, and this would be adding power to our grid.
We could possibly take a couple of those offline.
Right, and that should allow us to either make the power we need if all of these are required and still not enough, or maybe we actually can take some of the non-renewable power offline. It'd be a great exercise for students to see how much they could run in each house with no conventional power plant running. A solar electric array, a PV array for the houses. One array consists of two little panels here and a couple of widgets, which I'll explain. We have 3 of these setups for it. We don't have one for every house here because not every student is likely to get to this. So we've got 2 panels, and there's 2 different ways to hook them up. We can hook them up as a grid-connected system, which means it'll add power to the house, or we can set it up to store energy in a capacitor, which is like a battery, for when the power is completely out, the grid is down, and then you can charge it up in the sunshine and then bring the capacitor over to the house, the battery, and hook it to the house. So first I'm going to show you hooking it up as if it's grid connected without the battery storage. This sheet, there's a link to printing this sheet, and you need this sheet. I need it every time I hook it up. So first I'm going to hook it up as if we're going to do a grid connected system. So we take we're going to put these 2 systems, these 2 panels in series. So you can see we've got positive from one hooked to negative from the other. And then we're going to put this diode in here. A diode is like a one-way gate for electricity. We'll set it up so that the power will flow from the panels to the house, but it can't go the other way, so it won't drain the batteries that are powering our system back at the grid operator station. So let's see, which way does this go? This is the positive end, and that goes on the red side. And then we can hook this to the house with a couple of clip leads. Let's see, where's some clip leads? Here we go. And we'll go from the diode to one side of the house, the positive, and we'll go from the black negative to the other side of the house. And then if we don't have any sunshine, we have a incandescent light bulb here. These halogens are really bright, so you want to be sure that they don't shine in students' eyes. Go ahead and plug it in. There's no switch, you just got to plug it in. Oh, we're running you can see we're running our house. We've got the motors running on solar power. Hook up the solar panels here to this capacitor with the diode, just like in the diagram. Remember, you got to get this out. I have to every time I do it. So I'm hooking up the positive, and this time I'm hooking it up through an ammeter. So I'm going to measure the current. Go ahead, fire us up on some light. Here you can see the amount of current. It's 34 milliamps, and it's charging the capacitor. And as the capacitor gets full, this number will get smaller and smaller and smaller, because once it's full, it won't accept any more current. So fire it right up in there, get a little closer.
And we hooked that one up in series.
Yeah, the ammeter goes in series. You can see it's
One
just
big loop.
Yep. If we want to know how much voltage, we can look at a 0 to 20 scale on the DC voltage, and we can see that our panel is putting out 4 volts, or our pair of panels putting out 4 volts. So we're charging our capacitor just like it would be a battery in a photovoltaic system, because the power's out, and there's been a tree falling across the power lines. We've got no power at our house, and we need our lights. Okay, we're fully charged. Now we disconnect our capacitor, And we have to have the positive side of the capacitor, which is the longer of the two legs. One's a little bit longer. It turns out to be this one. And I think we had it hooked up with positive on this side, but we'll see. Ah, look, we're running our lights. No grid. We have stored solar power here, and it's going to run our lights for a little while.
When working with electricity and electrical circuits, nothing can be more frustrating when a light doesn't go on. And there can be several reasons for that. So here are some troubleshooting tips that might help you out. In the first part of the lesson, you'll be hooking up LED bulbs into the home. And as said in the other video, LEDs are kind of a one-way street in electrical terms. So I suggest putting the alligator clips onto the LED leads and then hooking it up to the house current. And you can just touch to see if it works. If you notice, the light goes on right there, but if I did it the other way, the light would not go on. So click it in the way that gets the light to go on. So always have the students check it. If they say the light's not going on, they can always switch it to the other lead of the two positive and negatives, the positive and negatives you have on top of your house. To check that the grid is working, we have this little LED bulb, but it might get so dim that you don't notice that it's on. So another way to check that the actual power lines of the grid is working is by using an LED bulb itself. You can put it, straddle it against the two. If it doesn't work one way, flip it the other way. And you can see right there that I got the bulb to lit. That means there's power to that one and power to that one. So that's a way to check that you have power to both of them by using this as a tester. The third thing you want to make sure you do not do is don't short circuit the system. So for example, if you have this one over and it goes over that way and touches that line, it short circuits the system and everything is not going to work as it should. So make sure that it's always clean. Get a grip so it's clean of the other wire and just move it over so it doesn't touch the other one. And make sure the two alligator clips leads do not touch each other as well. Also, when you're hooking up the motors have a very thin wire with just a little bit of metal exposed. And when you grab it with your alligator clip, you have to make sure you're grabbing metal to metal and not grabbing the insulated coating on the wire. That'll keep it better. And now this motor is going. I can feel it going right now. Always make sure you have good connections and don't be afraid to take the things off and start over again. Try to use 2 different color wires for each device that you're hooking up in the house. If you do both black wires, sometimes it can get confusing. So like here we have a black and a red or a black and a white wire. That would help you when you're trying to trace where the wire ends up. This is definitely a trial and error type of kit, but students seem to really enjoy it. So take your time. Teachers, tinker around with it first before the kids come in, and then you can help them try to figure out what might go wrong.